Hi, I'm Vishwa.
And I'm Adrian.
Have you ever tried to balance a book on your fingers? It's a lot harder than it looks. That balancing point where you want to place your finger is called the centroid.
In geometry, the centroid is the mean position of all points in a two-dimensional shape. This point will be the center of mass if the shape is made of a uniform material. For example, a circle centroid is right in the middle of the circle. A rectangle centroid is where the line that connects the midpoints of the top and bottom intersects the lines that connect the left and right sides. A triangle centroid can be similarly found by drawing lines connecting each vertex to the midpoint of the opposite sides.
Understanding centroids is very important when we work on boats, submarines, or blimps. In 3 dimensions, we refer to this as the center of volume. This is the same idea as the two-dimensional centroid, just extended into the 3rd dimension.
For instance, with the book Vishwa had balanced on his finger, if you're really talented, you can find balance points for all 6 sides.
For a blimp, a submarine, or a boat, buoyancy acts at the center of the displaced volume. Let's take a look at this on our blimp. The center of volume of the blimp is where the center of buoyancy is. This also lets us see why we want the center of gravity of the blimp to be below the center of buoyancy. With this blimp, the center of buoyancy is roughly here, but because of the added weight of the battery and the center of gravity is about here. When the center of gravity is below the center of buoyancy, like it is here, the blimp settles and the system is stable. But if we rotate the blimp a bit so that the center of gravity is above the center of buoyancy, then the gravity acts down from the center of gravity and buoyancy acts up from the center of buoyancy. The blimp will want to roll over until it reaches a stable equilibrium with the center of gravity below the center of buoyancy. Let's see this in action.
Roll this guy over, gravity, and flip right back around. And there you have it, a quick crash course on centers.